So continuing in section 1.2, we want to talk about what function notation is. So this is a special notation to represent a function if it fits our definition that we had given on the previous page. So, and it's this f with the parenthesis x, close the parenthesis. It is read as f of x. Or you can say f at x, where this represents the value of the function at the number x. Here is an example of a problem that you might encounter. So sometimes equations, you'll see them written like this. Here is an equation. It says x, get up a little further here, it says y is equal to x squared minus 2x plus 7. So because this equation fits the definition that we talked about, it can be, the y can be replaced with this function notation f of x. So it is the same thing as if you had the output of y. It's just the way to represent a function. And so the problem that it asks us, it says to evaluate f at -5. But before we do what it is asking us to do, let's talk a little bit more about what this function notation means. So first I have this letter f at the front. This doesn't mean f times x. The f just stands for the name of the function. Because you could have on the same page, you could have multiple functions. And so you need to know which function am I using. What if I'm going to evaluate -5 in one of the functions, I have to know which one. So I want to evaluate it in function f. That's the name of the function. So, and if I want to evaluate it into function g, you would see me write g of -5 or g at -5. Next, we have this, whatever is in the parenthesis here, in this case x, this is the input. In this case, it's saying f at -5, so my input is -5. Then you take that input and you do this rule on it. So this is the rule. It tells you what you do to the input. Once you perform that rule, you're going to end up with an output, and that is our y, or when we write it in function notation, the f of x. So let's take the problem we were given. The problem was to take this function, I wrote it here already, and I'm going to evaluate it at -5. So I'm going to rewrite the function, but wherever I have an x, I'm going to put a blank spot. So I'm putting these blank spots there, and I'm going to plug in -5 in all of the blank spots. In this case, we have 2 on this right side to fill in -5. And then I do the work. So -5 squared. -5 squared is -5 times itself twice. When you take two like signs and you multiply or divide them, you end up with a positive result. So this will be positive 25. -2 times -5, also two negative signs multiplied, two like signs, you'll end up with a positive 10. So I'm going to end up with 35 plus 7, which is 42. If I was to write this as an ordered pair, my input is -5, my output is 42. I always put x comma y. In this case, x comma f of x. Input, output. We can also do this on the graphing calculator. So, and we can check the answer we came up with on this calculator. So let's put it in as I had it written on my page. -5 squared minus 2 times -5. Notice when I'm inputting -5 on this calculator, I'm hitting the negative sign that is to the right of the decimal place. If I hit the minus sign, so in this case I hit the minus sign, the calculator is looking to subtract it from something. So if you want to represent a negative number, you put the negative sign, and if you're performing the operation of subtraction, you put the minus sign. So when I hit enter, I get 42, which is the same thing that I found by hand. Now, another way you can do this problem in the calculator is to take whatever your input is and hit the store button. Store it as x. Then type out the rule, x squared minus 2x plus 7. Now the calculator will take the number you store as x and put it in for x here, and you'll get 42. So our ordered pair was -5, 42. And that, because sometimes you'll have a whole list of these. So we could put in, let's say the next one said f at -3. I could put in -3, store it as x, hit enter. Now the calculator thinks whenever I type x, that means -3. Now instead of retyping this, I can hit second entry, the second enter button, and to pull down the previous line. And if you hit it a second time, it'll pull down the line 2 before it. And now I don't have to retype that. I can just get my answer. So now I have another ordered pair, -3, 22. And if I take all those ordered pairs that I come up with and I graph them on an XY plane, I will create a graph of the function. So we're going to do that next with two other functions. So here I have two other functions, and it says let's take this and let's graph 2x and let's graph 2x minus 3 on the same rectangular coordinate system. And it says select the integers for x starting at -2 and ending at 2. So what we're going to do is we're going to take over here, we're going to write f of x equals 2x, and I'm going to create a table. This is my input-output table, or my XY table. Now, the problem says start with -2 and end with +2. So it's telling me what x's to choose. So when I input -2 here, 2 times -2 is -4. 2 times a -1. So I'm putting in -1 for x now. I put in 0 for x, 2 times 0. And 1 for x, 2 times 1. And 2 for x, 2 times 2, or 4. And then I'm going to plot all of those points. So whenever you're plotting, you take the x value and you move horizontally. So -2, and then I go vertically down to -4. Then I take -1, and I go vertically down to -2. I have 0, 0, 1 horizontally up 2, and 2 horizontally up 4. And I end up with this. And then I would take a straight edge and I would draw a line connecting all those points. So it looks something like this. Now, I'd like you to pause the video and do the same thing with g of x. So create yourself a table on this side and call it x g of x. Start with -2, end with 2 for the x values, and calculate what numbers you would get here. So pause the video and try that, and then we'll come back and we'll check your answer. So I took the x values from -2 to 2. I plugged them into the function. These are the corresponding outputs. And then I took each of these ordered pairs and I plotted them here, connected the points with a line. Here are the two, I've graphed the two functions on the same xy coordinate plane.